Good morning, welcome back to the channel. Today we've got a pretty average job. It's just some maintenance work really, some reactive maintenance. We're changing over 7 110 volt transformers with like sort of sockets on them as well. So yeah, they're all like burnt out and abused. I don't think they've seen any sort of attention since the day they were installed, but we're here today to swap them all out. I'm going to show you what that involves, the process of sort of changing this sort of stuff over, and we'll also talk about transformer theory a little bit, how these things work and how they achieve that 110 volt voltage as well. Before we get into the video, if you haven't already, please like, subscribe and hit that bell button. And yeah, let's run the intro. So this one is 7L2. So far we've got 7L1, 7L2. I think there was some spurs next to some of these and some isolators, but I don't think they've actually got any local isolation. I think they are just fed from the board. They're 3 kVA, just little dual socket transformers, and we've got direct replacement. So once the circuit's isolated, it should be pretty straightforward to just swap these out. We've just got a bit of Copex coming out of the trunking to feed them. But yeah, 2 circuits so far. I reckon the other 3 will probably be on another circuit. Let's go find out. Okay, 7L2 again. L2. L1. Okay, so it can't be anything in there because anything after 5 doesn't exist in that board. This one's on 8L1. We've also got some burnt out contacts on this one, so you can actually see it quite clearly on this specific one. That's actually the live pin. It just shows where it's been getting really hot. There's also like a build up of like dust and grime in there, which doesn't help. That's basically where they're just pushing these sockets to their limits. These are 16 amp sockets, and yeah, they've probably got grinders in them and stuff like that. Those, you know, those high loads for prolonged periods. What you find with a lot of 110 equipment is because the voltage is different, it changes the whole equation. I equals V over R. So yeah, the amps can actually be like, you know, 16 amps or more quite commonly, rather than, yeah, just rated to what the socket can take. You see it a lot on sites where people are running welders and grinders like all day. The site transformers are always burnt out, so yeah, those tools could probably do with a bigger plug on them. You do see it quite often, and yeah, that's what it looks like, a little burnt out pin there. Let's go to the board now and see if the stickers on these correlate with the stickers on the board. Right, so let's see if we can get this wedged. Lovely. So this has actually been all opened up by the maintenance team. Normally this would all be locked. And in here we've got a load of circuits. So it was 7L1, door 240 110 power, and 7L2 sidewall 240 110 plus PC power. That one's on an RCBA, so is that one. and then it was 8L1 back wall power plus oil system, and 8L2 back wall power. So we need to check the oil system for sure, see what that affects by isolating this circuit. We also need to check the PC power. Everything else just looks like small power, so you know, chargers, radios, stuff like that, we're not really going to affect anyone. But what I don't want to do is just bang all these circuits off and crack on, and then yeah, annoy all the guys that are trying to work in there. Everything seems to not really matter, but yeah, that oil system sounds important, and I just want to make sure I'm not turning off, like, you know, the booking in PC or something like that. So yeah, I'll go speak to some guys about that, and then we'll unbox one of these new transformers. So I've just been round. We haven't got to worry about the oil system. It's just an oil pump basically that they're not really using today. There's a PC down here as well, which again, if I notify them when that's going off exactly, they'll be cool. So we're pretty free to crack on. I'm going to unbox one of these new transformers and try to show you the internals, and then maybe we'll get a magnetic core out of one of the old ones, and I'll be able to talk about how that works and show you that in practice, which will be pretty cool. So I've got one of the covers of the transformers off. These are made by JMS, so they're pretty well known for their transformers actually. They do site transformers, all sorts of stuff like that. These are obviously little wall-mounted transformers with 2 sockets on like the other ones, and inside we've got various components. So I'll start with the circuit breaker. This is a little 6 amp circuit breaker. It works with a bimetallic strip in there, and yeah, works on basically overload, and it cuts out. It can be reset. The actuator can be reset by pressing this button here once it's cooled down, and that is your live in point. Something I don't actually like about these is they provide you with this crimp terminal without any cable. This is something I've made up, but this is your incoming point. So if you have 2 cables like we have, I'm actually gonna have to send this lead to a Wago, and so I can get 2 cables onto this live in point. It is what it is, and I can work around it. The neutral goes into this connector block here, which gets sent straight into the magnetic core. The magnetic core I'll talk about in detail on a one I've actually stripped out of another transformer. I'll show you how that works, so we'll gloss over that for now. And then we have the output terminals. So here we've got 110 out, and then 2 sockets, 2 16 amp commando sockets there. So yeah, pretty simple components wise. This thermal overload is actually quite forgiving. You can overload it at about 200%, 150, 200% will last about an hour. After that, it drops right down to like 5 seconds trip time. So yeah, you don't want to go too far with it. Designed to obviously be ran at overload sort of currents if need be. Let's talk about this magnetic core now. So this is one I've actually stripped out of one of the old ones. It's very similar. Like I said though, you've actually got 3 terminals here, which is a bit better. You can get 2 cables in them, then it gets sent to the circuit breaker, to the overload switch, and then it goes into the center tapped transformer. So a bit of a better design. I'm going to try and explain how this works now as best as I can. But basically, you have the magnetic core, and then inside you have 2 sets of windings, a primary and a secondary winding. So on the incoming side, on the primary, we're sending in 230, 220, 230 into here, and then there's a load of coils in there, and dependent on the amount of coils on the input and the output, through the magnetic core, through the powers of induction, it will actually output a different voltage. Now, I may be wrong, this is where my knowledge of this gets limited, but I'm pretty sure on this center tapped transformer, there'll be less coils on the secondary winding, half the amount, or give or take half, and that will then mean that the voltage will be half, and that will present a 110 voltage. And then what they do is they center tap the earth off of the middle of the windings. What that means is to earth you will get 55 volts. So if there is a fault presented at any one time, the touch voltage, or the voltage that you're going to come into contact with, is limited to 55 volts. Now, of course, that's still not great. You can still die from 55 volts, but it's far better than 110, and it's far better than 230. So that is why yellow sockets, site transformers, all that sort of stuff, use center tap transformers. You know, of course you could just transform it down to 110, but the reason why they center tap it is because you're limiting that voltage to actually 55 volts. But yeah, I've probably completely butchered it if you ask like an electrical engineer to explain it, but hopefully it's been helpful to you guys, and hopefully that makes sense. And if I have got anything wrong, I'll be being corrected in the comments anyway. But yeah, that is the theory behind these. So I'm just prepping all the fly leads basically in one go, getting organised. And what that means is I can then say the word organised in the video, and then I can link that word to today's video sponsor, Traderfy. So as you know guys, Traderfy have been a long-term sponsor of the channel. For those who don't know, they provide job management software. You can basically input all of your jobs into it, quote them, keep track of them. If you've got more than one staff member, you can, you know, track the staff, how long they spend at each job, where they're going, plot all the jobs out on the map, loads of stuff to get you and your business organised. As always, I've got a discount code Residual, that will give you 50% off 3 months. But what I would say to do first is jump on a 14-day free trial, see if you like it, because you do have to break some, if you're lazy like me, unorganised like I was, you do have to break some quite bad habits and get organised. See if you can get on with it over the 14-day free trial, and if you do like it, then grab 3 months at 50%, really get used to it and see how it works for you. As a sole trader, it served me very, very well. Try it out and let me know what you think. Code Residual. Who glued this to this? I can't bolt it, it's the new one though. People always say that commercial and industrial is cleaner electrical work, it's cleaner work, but in my experience, it's always been dirtier. But anyway, we are having some lunch, we're about halfway through. Today, I have an Asda ham and cheese sandwich, squares, love squares. Tree bore soft mints, I'm a sucker for tree bores to be fair. I do sometimes like the hard ones, but the soft ones are banging too. And then we've got 24 mini flapjack bites. These are actually Jude's. I'm just gonna have a couple of them. Jude's gonna put most of them away, and then he's gonna use it to sweeten up the mechanics as well, because he's moved all their stuff out of the way and they're pretty pissed at him. Also, the first time I've tried Apple Blast, which was Jude's recommendation, every day he comes into the office with is it a 1 litre? A 1 litre of Apple Blast, and he's drinking it from 8 in the morning till 4 o'clock in the afternoon. So I thought maybe that's his secret, you know, to his hair, to his skills with the camera. So I thought I'm going to try it, and to be honest, I haven't noticed any changes, but it does taste pretty banging. I'm going to put all this away, finish off the last, we've got like 2 to do, haven't we? And then one of those I'll make sure I slow down a little bit and show you guys exactly what's involved with swapping one of these over. So this is the second to last one, and I thought I would take you through the full process. So we've actually already got this circuit isolated, or so we think, because it's on the same circuit as the previous one. Now, there's no cables in this one. Do you need a camera? So that's caught me by surprise. I wasn't expecting that. This one is not actually wired up, so I guess we'll leave this one. That one, yeah, that one obviously had cables in, we changed that one. But this one don't. So I might take it off the walls, save any further confusion, and I guess we'll jump over to 7L1 and change both of those. But yeah, to be continued. I've just gone and isolated this one. This is the last of 2. It's actually worked out quite well, because the one with no cables in, I think wasn't counted anyway, or maybe they missed out one. There's actually 2 more that are broken. So yeah, it was good that that one was a false one, and we've got 2 transformers left, because yeah, there's this one and another one to do. So it's worked out well. These ones, they've taken a bit of a different approach. You might have seen from some of the earlier clips that these come with sort of knockouts either side, and we've been utilising them. But these ones, they've actually come into the back of them with 25mm Copex. So I'm going to have to follow suit and do that because the Copex isn't long enough to do anything else. However, there is just 3 cables on this one. It's end of line, so that's nice. Lovely job. And now I'm just going to test between live and earth, neutral and earth, and then neutral and live. And we are all dead. I'm going to jump back on these, prove the testers again, and that is us safely isolated. Just disconnect these. So this is the end of a 4mm radial. Get the Copex loosened off. So I'm just spinning basically the back of the Copex gland, holding onto the lock ring, and that's allowing me to just spin the lock ring off because transformers get very warm. This is nice and toasty in here even now, even though it's been turned off 5 minutes. So this plastic is obviously expanding and going brittle basically. It's not there yet, but yeah, those glands were pretty tough to undo, but by being able to grab hold of this and just spin this made it a bit easier. So like I said before, these transformers come with 2 20mm knockouts either side of them, which is handy. But what it means is if you're not going to use them, you want to cover them, and they've opted for the bung sort of route. Now they actually had both of these lock rings on the inside because you've got this dead sort of bit of metal with no thread on. You do need 2 lock rings, but what I actually like to do is put one on the outside like that and then bolt it through with one. It just gives you better coverage. Some people won't like that, but I think it's all right. Pop that there. Get the other one out of the way. I want to go behind these, grab hold of the nut, and then loosen these off. I'm actually just going to reuse these fixings, but I am going to chuck in a penny washer, I think, especially both sides, but mainly for the back. The nuts are tiny, the little roofing nuts. So yeah, they sort of like perforate the tray basically. They yeah, sort of dig into it a bit. They don't really spread the weight that well. So right, I'll get all 4 of these off, and then yeah, we'll sit the new one on. Should. There we go. Lift off. Oh. Oh. I want to get this one. Oh. Next to it. And we want to get these holes drilled in the same place pretty much. I mean, there's quite a big hole on the back there, but we still want to be roughly accurate. It's interesting to see the 2 next to each other. They very similar but very different. These got old wiring in them as well. Better terminals on these, but yeah, obviously your core's coated and stuff like that. It's just a little bit, there's a little bit more future proofing in this, I guess. I'm gonna go grab a tape measure and a Sharpie so I can get this measured, and then yeah, we'll get that drilled out. Then it's just a case of chucking it on the wall and connecting it up, which I'll run through with you. I've cut my hole in exactly the same spot. Now I'm just gonna get my penny washers ready, because I'm gonna try and yeah, have them on the front and the back just for a bit of better weight spread basically on the tray. I'm going to start with 2 of them. Let's see how we get on. I've got one in. We get a nut on, just finger tight. There we go. I can see that I'm level because of the tray, so that's good. Get them finger tight, and then I'll sort them all out afterwards. This one is cross-threading, which is annoying. It's as simple as that. I've got my hole in the back there, which I'll utilise in a minute. But yeah, it's just bolted to the tray like so. One more there. one more there. Pliers, so I'm just using these to grab hold of the nut basically, and then I can give it a good couple of turns to really really get it tight. I'll chuck the bungs in now. You can see with the lock ring on the outside, they just cover holes better. It still does its job of obviously reducing the length of the thread so that you can get a decent bite on it with the lock ring to tighten it, but it just creates a better seal around the outside, to be honest. Finger tight, and then just want to nip them up with the grips. Lovely. I'll just crimp that on, which is a bit better. Before I was having to go from one cable out of that crimp into a Wago, doing it sort of that way, which wasn't ideal. But yeah, with just the one, because it's a radial now, end of line, I can just bosh it straight into the one terminal. Same with the neutral, that can just go straight in. Then the terminals with like the bit of metal in the cage, there's like a bit of metal which a screw pushes down on top of the cable, and like I know what it's there for. It arguably, well, it does provide a better connection on smaller cables, but when you're trying to get a 2.5 or a 4mm in, you just don't need that there. It's a bit annoying, but cool, that's done. And then basically I want to grab a blue eye crimp, and I haven't got any there, but bolt it onto this little bolt here, and that is basically my my earthing point. All the earths do get sent back to this main one here, but yeah, that's where I'm going to bolt this green and yellow one, shove the cover on, and then just need to label it up then, do the other one on the same circuit, test it, and job's a good one. So I'm going to smash this one and the next one out, and I'll probably catch up with you guys quickly while we're doing the minor works. Right, so I've got the cover off the board. I'm about to do some testing, and that's because we need to provide 4 minor work certificates today, one for each circuit we've touched. Although we haven't done a lot to them, we haven't changed any resistances, we have messed around with them, so they do want a minor works for each one. Like I said, I've got the cover off. I'm going to be taking a ZE here with the mains earth connected. I'm not going to be disconnecting that for this test. I'm just going to get the result with it connected. I'm going to be doing a PFC as well at the same time. Jotting that down and just getting all the mains characteristics to write that down on the certificate. We will then go out to the field, to the end of the circuit, and we'll do R1, R2 testing, linked out here, or probably at the end of lines would be easier, and do some ZS testing as well. I'm not going to go through all of it. At some point I will do a video. But yeah, I just wanted to quickly show you a few bits before we wrap this one up. I'm going to shove this onto here, like so. I'm onto the loop setting, I'm onto the 2 lead setting, and I'm just going to jump onto this breaker here. There we go, and I'm going to press test. 0.19, 1200 amps, 0.15, 1600 amps, 0.16, and 1400 amps. So let's jot this down on notes. New note, 0.16 was the highest, and then 1600, 1.6 kA. We do want to double that because it's 3-phase, but we're also just going to do to neutral quickly, which is going to involve me taking that cover off, which I don't really want to do. We're going to do it here, so let's push this onto lock mode. Okay, so we've got 1300 on that one. Just engage, okay. 1300 on that one. It's bound to be exactly the same. Yeah, cool. So 1.6 kA is our PFC. Our PEFC was the highest. Our PSCC was 1000, and then 1300. So yeah, the PEFC was the highest at 1.6 kA, and I'm going to double that because it's 3-phase. and that will give me a PFC of 3.2 KA. Do you know what? I haven't done any testing in a long time, but it all comes back to you pretty quickly. I'm going to get the rest of the mains information, supply characteristics and stuff like that, all that boring stuff, and then probably catch up with you doing some ZS testing, and then yeah, I'll show you a bit more of this tester, and that'll probably be it. But yeah, give me a sec and I'll see you over by the transformers. Right, so I'm just doing the first of my ZS's, so just using this plug here. I've had the trunking lid off just ever so slightly. Turns out this is end of line of the same circuit, and that's 0.32. I'm now going to jump onto RCD mode. Let's write that down though. 801 0.32, cool. And then we're going to do a RCD test on auto. So I'm going to push this button. Yeah, it'd be a different one, but yeah, you go flip the breaker. We've got our first result. 1 times, well, we've had half times, we've had greater than 2000 milliseconds. 1 times at 0 degrees, 41.1. 180, 45.8. 5 times 24.4, 0 degrees. And then 5 times at 180, 29.1. So, don't know if you can see because it's sort of blown out, but there we go, that's better. So you can actually see on the screen there, you've got all of the results on one screen, which is just dead handy. You can visually see everything. You can take a picture of it as well for later. One of my favourite features of this tester is how it does that. We're going to run around, get the rest of the test results, and I'll catch you guys by the van to outro this video. Right, that is it for today. Another day in the life of a commercial industrial electrician. I can't remember how long ago. That's what I used to call every video, a day in the life of a commercial industrial electrician. 1, 2, 3. Now I've changed all the names now, I just write whatever, but yeah, I literally used to call every video that. But that is enough for today. Hopefully you found it interesting. Like I say, a pretty basic job, to be honest, nothing exciting, but took you guys along anyway, and yeah, spoke about transformers, just showed you what was involved. As always, if you haven't already, please like, subscribe and hit that bell button. It supports the channel, but more importantly, if you like the content, like what we do, you're just up to date with everything we've got coming out. Check out Tradeify, like I said, banging job management software. I don't get any money for signing up, but they have sponsored today's video, so shout out to them. And also check out Loadout. All the tools you saw me use today, everything in my tool bag, all of the kit, is all available on Loadout, my tool shop. So yeah, go check that out. We've got loads of deals on at the minute, massive Nipex promo, and yeah, just loads of tools and equipment available. Thanks for watching, guys. I'll catch you on the next one.